Hello, everyone, and thank you for attending this session. My name is Navdeep Singh, and I'm an independent researcher affiliated with the Pennsylvania State University. Today, I'm excited to present my research titled Personalized Product Recommendations in E commerce using Machine Learning Techniques. As online shopping continues to expand rapidly, ensuring that users find exactly what they're looking for has become a critical challenge for online retailers. My work focuses on building a highly accurate and scalable recommendation framework to address this exact challenge. Here is a brief overview of what I will be covering today. I will begin with an abstract and introduction to frame the core problem. Then I will touch upon the existing literature to highlight the current research gaps. From there, I will dive into the proposed methodology, including our data pipeline and ensemble model. Finally, I will discuss the results, outline some limitations and future work, and wrap up with the conclusion. To summarize the core of this research, personalized product recommendations are essential in modern e commerce platforms as they directly improve customer satisfaction and conversion rates. In this paper, I propose a hybrid ensemble machine learning framework. This system combines random forest, XGBoost, and light GBM alongside stacking, soft voting, and bagging techniques. My framework leverages a mix of transactional, behavioral, and contextual data, and we specifically tackle class imbalance using SMOT. Ultimately, our experimental results demonstrated a highly robust performance, achieving 97.69% accuracy and 99.40% F1 score, significantly outperforming the traditional models. We also integrated SHAP analysis to ensure these recommendations remain transparent and interpretable. Let's look at the motivation behind this work now. The rapid growth of e commerce has led to massive increase in product variety, which often causes information overload for customers. It has become increasingly difficult for users to simply locate the products that fit their specific preferences. To address this, personalized recommendation systems are widely used in online retail to analyze user behavior, purchase history, and product attributes. However, traditional methods such as content based and collaborative filtering suffer from notable limitations. These include data sparsity and cold start problems, and limited personalization, of course. Furthermore, many existing legacy systems struggles to adapt dynamic user preferences or account for contextual and business related factors. To bridge this gap, my paper introduces a scalable hybrid machine learning framework by combining collaborative and content based methods with real time interaction data. We aim to deliver highly accurate, adaptive, and content aware recommendations. In reviewing the literature, we examined several recent advancements in machine learning for e commerce. For example, Gorinthala achieved 95.8% accuracy using GPU accelerated YOLO ensemble model for sentiment detection. However, they did not address dataset imbalance or scalability. Kumar and Ahuja proposed a hybrid model using SVD++, TF-IDF, and XGBoost, achieving a 92.17% accuracy on an Amazon dataset. But their evaluation was limited to a single dataset, which restricts generalization. Similarly, Beller utilized deep learning models like CNN, RNN by LSTM architecture, reaching a 96.2% accuracy, but focused predominantly on sentiment analysis rather than actual product recommendations. The primary research gap we identified across these studies is lack of integrated models that effectively combine interaction behavior, contextual relevance, and class imbalance management and explainability. Our study specifically addresses these limitations. Moving on to our methodology, this flowchart illustrates our end-to-end pipeline. We started by loading a customer dataset and a product recommendation dataset each containing 10,000 records. During pre-processing, we removed irrelevant columns, combined browsing and purchase histories, and created a structured interaction format. We engineered 13 new features across categories like price sensitivity, sentiment, and user engagement levels to enrich the dataset. After encoding categorical variables, we split the data into 70% training and 30% testing sets. A significant challenge was class imbalance. Our initial dataset had 151,784 positive interactions compared to only 57,869 negative ones. We utilized Smote on the training data to perfectly balance the classes. For the model development, we built a hierarchical multi-level hybrid ensemble. At the base layer, we trained random forest, XGBoost, and light GBM. We then combined their predictive power using stacking with a logistic regression, meta learner, soft voting, and two bagging ensembles. This multi layered approach was designed to maximize predictive robustness. To further validate our results, here are the confusion metrics and ROC curve for the best performing model. The confusion metrics on the left displays excellent predictive capacity. One out of all the test samples, the model correctly identified 24,604 true negatives and 63,367 true positives. The misclassification were remarkably low, with only 634 false positives and 1,247 false negatives. On the right, the ROC curve confirms the model's outstanding discriminative ability. The curve hugs the upper left corner perfectly, resulting in an area under the curve, or AUC, of 0.996. These visual metrics confirm that the model effectively separates classes with robust predictive power. While high accuracy is great, transparency is equally vital for e commerce platforms. We used SHAP to interpret our model. As shown in the feature importance chart, the most influential factors driving our personalized recommendations are sentiment category, interaction type, and product rating. This means the model heavily relies on customer sentiment, user engagement levels, and overall product quality to make decisions. Secondary attributes like price to average order ratio and seasonal relevance also play a meaningful role. By implementing SHAP, we ensure that our highly complex ensemble framework remains intuitively explainable, fostering trust in recommendation it generates. To contextualize our success, we compare our hybrid ensemble model against recently published frameworks. As detailed in this table, models like the MLA EDTC net by Krishna achieved around 83.6% accuracy, while traditional ML classifiers reported by Omima, such as SVM or Decision Tree, hovered around the 64 to 66% mark. Even advanced deep learning models like RNN hit 94.85% accuracy. Our proposed hybrid approach surpasses all of these benchmarks across every dimension evaluated, proving that our specific combination of stacking, bagging, and engineered contextual features provide a superior, highly balanced recommendation capability. Despite its strong performance, our model does face some practical limitations. First is the inherent cold start problem. New user or newly listed products with limited interaction history can initially cause a dip in recommendation accuracy. Additionally, deploying this system across massive user base and product catalogs introduces computational cost and demands highly efficient distributed processing techniques. Finally, leveraging detailed behavior data inevitably raises privacy and data protection concerns. For future work, We plan to explore incremental learning to handle real-time data efficiency and federated learning architecture to resolve primary issues while maintaining robustness. In conclusion, we successfully developed a hybrid ensemble framework for personalized e-commerce product recommendations that integrates random forest, XGBoost, and light GBM using stacking, soft voting, and bagging. By successfully mitigating class imbalance through SMOT and incorporating highly engineered behavioral features, we achieved an exceptional 97.69% accuracy. Furthermore, our SHAP analysis ensures that our model is not a black box, but a transparent tool that identifies sentiment and interaction type as core drivers of recommendation. This scalable framework provides a highly practical solution for online marketplaces to enhance customer engagement and boost conversion rates. Here are the core references that guided our research methodology and literature review. Thank you all so much for your time and attention today. In case if you have any questions for me, you can reach me on the on-screen email.